Welcome all. Today we are going to discuss about maximum likelihood estimation for a uniform distribution. We all know that suppose the random variable xi follows uniform distribution 0 theta, then the PDF of that random variable will be f of xi is equal to 1 by theta, where the limit will be 0 less than or equal to xi less than or equal to theta. Why I am writing xi here is like we are going to take the likelihood function. So just the notation, it is xi 0 otherwise. So this is the PDF for a continuous uniform distribution. We know that the likelihood function of the uniform distribution is, it will be product of f of xi, then I is equal to 1 to n, it will go like that. If we write, then it will be 1 by theta into 1 by theta into like that it will go. So it is 1 by theta raised to n. If we go to find the MLE for the a maximum likelihood function, maximum likelihood estimator for the uniform distribution, we will end up with the MLE will be theta cap is equal to, it will be xn, and the xn means the maximum of x1 etc x2 etc xn. It means xn is the order statistics. In the sense of order statistics, we represented this way. So what it means, suppose the random variable n random variables are there named x1 and my higher one like that, the ascending order. If we are arranging that, the higher the value it will be, we represent this in the way of x n. So the MLE, the maximum likelihood estimator for the uniform distribution, is xn. We found that likelihood function of the MLE, the likelihood function of the uniform distribution is 1 by theta raised to n. So it comes in the denominator. We already know that the likelihood function, the value of the parameter which maximizes the likelihood function, comes as the maximum likelihood estimator. It means the value of the parameter which maximizes the likelihood function, it comes as the maximum likelihood estimator. So how come this value, this higher order value, makes the likelihood function maximum? It comes in the denominator. We know that lesser the value can only make the function maximum. So how come a higher value makes the likelihood function as maximum? In this video we are going to see how it came. So for that, first we want to know the likelihood function of the uniform distribution. So it will be like, here we will plot L of theta on the y axis, on the x axis we will plot theta. So the likelihood function of the uniform distribution, it will be like this. So it start with higher order xn and it goes up to theta. So the minimum value, or the value that the theta can take, the minimum value that theta can take, like from this function we understood that the minimum value of the theta can make only this function maximum. The concept is the minimum value of the theta is the higher order statistic, the higher order xn. So the higher order can only make the likelihood function maximum. So how it is that we are going? For that we have to understand the likelihood function in such a different way. It means we know the likelihood function is 1 by theta raised to n. In that we have to add some indicator function where Indicator function we can represent it as 0 less than or equal to xi less than or equal to theta. This is what our indicator function. I will explain what is indicator function later. This is our likelihood function now. This is what till now we learned. We can write this likelihood function in such a different way that 1 by theta raised to n, the indicator function can be split into 2. Suppose x1, x2, etc. xn, that I already told this. Suppose we are arranging this in ascending order, then x1 will have the least value, so it will be first order, and xn will be the higher value, then it will be the xn higher order. So we can split the indicator function in such a way that the lower limit 0 less than or equal to the first order and indicator function xn the higher order less than or equal to theta. I will write here once more. It will be theta raised to n, indicator function of 0 less than or equal to the first order and indicator function of the xn, it will be the higher order xn less than or equal to theta raised to an indicator function. So the likelihood function will be on this way. It means the 1 by theta raised to n, indicator function 0 less than or equal to first order of a random variable, and the indicator function for the higher order of the random variable will be less than or equal to theta. So here you can see that the indicator function, the 0 less than or equal to first order of the random variable, that is pretty sure that, like, we know the limit 0 is less than or equal to the xi. For the random variable, it will be greater than or equal to 0. So the minimum value of the random variable, it means the first order random variable, it will be obviously greater than or equal to 0. So this indicator function is clear. The second indicator function, it means the higher order of the random variable. Higher of the random variable means higher the value of the random variable will be obviously less than or equal to theta. That also from this indicator function only we wrote these two indicator function. So before going in further, we should know what is indicator function. So indicator function is just a function. It has only two values, 1 and 0. 1 if that x, that value, if that value present in the set. Otherwise if the value is not present, then we will give 0. If the value is present in that set, then we will give it as 1. If the value is not present, then we will give it as 0. So let's come back to the likelihood function. We end up with the likelihood function is 1 by theta raised to n, the indicator function 0 less than or equal to first order of the random variable, indicator function the higher order of random variable is less than or equal to theta. Then we can rewrite the likelihood function of the uniform distribution. Here it will be theta and here it will be likelihood function of the uniform distribution. So the indicator function. So the indicator function represent the xn. Suppose the xn comes here. So the xn is the value, the xn is the minimum value that theta can take. Xn is the minimum value that theta can take. So that xn comes into picture of the maximum likelihood estimated. Because of this only the xn, the higher order of the random variable, comes into picture. Understood? Next we are going to see one more uniform distribution where the random variable for a uniform distribution with 0 theta. Then f of xi, the PDF, it will be 1 by theta 0 less than xi less than theta. Otherwise 0 it is otherwise. Then likelihood function we can write in the form of log theta. It will be theta raised to n. Here our likelihood function, it will stay in this way. here it will be theta, here it will be L of theta. So here our xn, our higher order for the random variable, it is not included. Before we have seen, what we have seen is we have the less than or equal to. Now less than or equal to is not there. So for this particular uniform distribution, MLE, that maximum likelihood estimator, doesn't exist. Thank you for watching.